Good morning, students. The next class on probability will continue with problems on independent events. Last class we studied what are independent events. When I consider independent events, it was probability of A intersection B is equal to probability of A into probability of B. So probability of A intersection B, if it is equal to probability of A into probability of B, then it is A and B are said to be independent events. We learned this in the previous class and we also started working out problems on this. We'll continue with few more problems on independent events. The next problem what is given here is an unbiased die is thrown twice. An unbiased die is thrown twice. Let the event A be an odd number on the first throw and B the event an odd number on the second throw. Check the independence of the events A and B. Now, what is the random experiment given? The random experiment is a die is thrown twice. So here the sample space when I consider, it is a die. The random experiment is nothing but a die which has 6 faces. How many times it is thrown? Twice. So 6 squared, that is nothing but 36. So total number of elements in the sample space is given by 36. Then the two events are defined. The first event says that an odd number on the first row. Now when I consider in a sample space, I know that it has 6 faces, 1 to 6. We have to consider the condition where an odd number appears on the first row. Now let me define event A. Event A when I take, here the condition are a die is thrown twice. So here I get back in the form of ordered pair where I define first row on the first coordinate and the second row on the second coordinate. So here I have to consider an odd number on the first row. So 1 is an odd number. On the first one it is 1 and the second one again it is 1. Then 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6. For on the first die, an odd number on the first row. So odd number is 1. That I have considered on the first row. But whereas on the second row, I have changed to all the 6 faces what is possible on a die. 1, 2, 3, 4, 5, 6. What is the next odd number on a die? 3. So I consider 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5 and 3 comma 6. On the first row, I should have an odd number. So I have taken odd number 3. And the second row, that is the second one, all the 6 faces of a die are replaced. 1, 2, 3, 4, 5. Now 1 to 6, we have 1 and 3 the odd number. What is the next odd number we have? 5. So I consider 5 on the first row because I want an odd number on the first row in event A. So 5 is an odd number. 5 comma 1, 5 comma 2, 5 comma 3, 5 comma 4, 5 comma 5 and 5 comma 6. So these are possible cases what I can consider in event A. When I consider event A, these are the possible cases what I can consider. So these are the set what I get back. Now, how many elements are there? The number of elements in event A. The odd numbers on the first row possible are 1, 3 and 5. But when I take the second row, I should have all the 6 faces. So 1 to 6. So here 6 into 3, 18. So there are 3 odd numbers what we have considered, 1, 3 and 5. With that each case for the second row, that is from 1 to 6. 3 into 6, that is 18. Then the next one I consider is event B. What is event B defined? Odd number on the second row. Just we have to reverse the odd number on the second row. Let me consider. We know that the odd numbers are 1, 3 and 5. That I have to consider on the second row. Whereas on the first row, I have to use all the 6 faces. That is from 1 to 6, all the numbers. So first odd number, I will take it as 1. Sorry. 1 comma 1, 2 comma 1, 3 comma 1, 4 comma 1, 5 5, comma 1 and 6, comma 1. Can I say this? Here you can see that the odd number should be on the second row. What is that second row? I have retained it as 1, the first odd number. And whereas the first one, I have taken all the 6 cases. The next odd number is 3. And on the first row, I will change to all the 6 cases. 3, comma 3, 3, comma 4, comma 3, 5, comma 3 and 6, comma 3. The odd number what I've considered for the next one is 3 throughout on the second row and from 1 to 6 on the first row. Similarly, the next odd number is 5. Whereas on the first row, I will consider all the 6 numbers. So the possible odd numbers what I can choose back are, I have 1, 3 and 5. These are the only possible 3 odd numbers what I can consider. So on the second row, they have told that an odd number. So odd number is maintained on the second row. What are the possible odd numbers? 1, 3 and 5. Whereas on the first row, I have taken 1 to 6 all possible cases. Then number of elements in B, again it is. First row I have 6 on the first row and 6 into 3, 18. 6 3s are 18. What else I require? A intersection B. We are finding the condition for independent events. Independent events when I have to take, I have to find out what is A intersection B. Let me find what is A intersection B. What are the common elements in these two events? When I take the common elements, can I say 1, comma 1? Okay, next possible cases 1, comma 3. Then 1, comma 5. So these 3 I'll list out first. 1, comma 1, 1, comma 3 and 1, comma 5. So I have the first cases 1, comma 1, 1, comma 3 and 1, comma 5. Those line. Then go for the next one 3, 3, comma 1, 3, comma 3, 3, comma 5. 3, comma 1, 3, comma 3, 3, comma 5. 3, comma 1, 3, comma 3 and 3, comma 5. The next one what I can consider is for 5. The next row 5. 5, comma 1, 5, comma 3, 5, comma 5. Again in event B do I have? Yes, 5, comma 1, 5, comma 3, 5, comma 1. 5, comma 1, 5, comma 3, 5, comma 5. So these are the possible cases which I have the common ones. The common elements in event A and B, I have taken these. How many elements are there? The number of elements in A intersection B is nothing but I can say 9 are there. Totally 9 common elements I get back. So I have found the number of elements in event A, number of elements in event B and number of elements in A intersection B. Now I have to find the independence. That is whether A and B are independent. Let us verify the condition. If I have to find that they are independent or not, we have the condition for that as probability of A intersection B is equal to probability of A into probability of B. Let me verify that condition. I find out what is probability of A intersection B. What is probability of A intersection B? Number of elements of A intersection B divided by the total number of elements. Number of favorable outcomes divided by total number of elements in the sample space. Probability of A intersection B is given by number of elements in A intersection B is 9 divided by how many elements are there? 36. Can I simplify this? 1 by 4. So 1 by 4 I get back. Then I find out what is probability of A into probability of B. I have to find probability of A into probability. Probability of A is number of elements in event A divided by total number of elements in the sample space. Number of elements in B divided by number of elements in the sample space. Number of elements in event A is 18 divided by how many elements are there? 36 into again number of elements in event B is 18 by total number of elements in the sample space. Can you simplify this? If I simplify this, what do I get back? I'll consider three tables. 3 6 are 18 divided by 12. Again here 6 by 12. Again I can cancel 1 by 2 into 1 by 2, that is 1 by 4. This I take it as equation 1 and this as equation 2. So I've got back probability of A intersection B is number of favorable outcomes divided by total number of outcomes. I got it as 1 by 4. That I've taken it as equation 1. Then probability of A into probability of B. I found the value after the simplification. I got back 1 by 4. I've taken that as equation 2. From equation 1 and 2, what do I have? From equation 1 and equation 2. If I compare, I can say probability of A intersection B is also 1 by 4, and even this value of equation 2 I got back 1 by 4, which is probability of A into probability of B. So from equation 1 and 2, I can say that probability of A intersection B is equal to probability of A into probability of B. That implies A and B are independent events. That implies A and B are independent events. This implies A and B are independent events. So that asks to verify whether they are independent events. You have found the event A and event B based on the condition given. First row should be an odd number. We have maintained the odd number. In event B, second row should be an odd number. Then we have found the respective probabilities and verified the condition of independent events. The next problem, what is given is, given that the events A and B are such that P of A is equal to half. They're given there are two events A and B and the probabilities of them are found. What is the probability? P of A is equal to half and P of A union B is 3 by 5. And P of B, probability of B is given as an unknown P. That is an unknown K or what you have to find. Here it is mentioned as P. Find the value of P if they are two conditions are given. Mutually exclusive and independent. So using the condition of probability of A, what is defined, probability of B is an unknown given and probability of A union B. I have to get back the value of P when it satisfies the two condition. Let us see how to satisfy this condition. Now the first one I'll consider is the first condition. What does it say? They are mutually exclusive. So when I say they are mutually exclusive, it implies probability of A union B is equal to probability of A plus probability of B. The first condition is given as they are mutually exclusive. When I say they are mutually exclusive, it implies probability of A union B is equal to probability of A plus probability of B. Let me substitute the value and try to find out the unknown, what is asked as P. Now, probability of A union B is 3 by 5 is equal to probability of A is also given. What is that? Half. Plus probability of B is nothing but P, the unknown. I have to rearrange this and get back the value. Shall I shift half to LHS to rearrange this value? If I shift half to LHS, it is difference of two fractions what I have. Now, 10 is the LCM. When I consider 10 as the LCM, 5 2s are, 2 3s are 6 minus 2 5s are 10. 5 is equal to P. So what is the value of P I get back? 6 minus 1. P is equal to 1 by 10. In the first condition, I get back the value of P as 1 by 10. When I'm using the condition, they are mutually exclusive. Now, the second condition I use is independent. When they are independent events A and B, let us see what happens. What is the condition for the independent events? Independent events implies probability of A intersection B is equal to probability of A into probability of B. Probability of A intersection B is equal to probability of A into probability of B when it is independent events. That is the definition what I have. In this, I know probability of A is given half. Probability of B is unknown. That is what we are trying to find. But I don't have probability of A intersection B given. Instead of that, I have given probability of A union B. Let me use the formula of probability of A union B and try to rearrange. I'll try to use the formula of probability of A union B where I get back the value of probability of A intersection B. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. And this is one more formula what we have by which I'll try to rearrange. In this, in place of probability of A intersection B, from the condition of independent events, let me substitute that. The second condition what they've asked us to consider is independent events. When I take the condition of independent events, I know that probability of A intersection B is equal to probability of A into probability of B. That I'll use it here. So independent events gives probability of A intersection B is equal to probability of A into probability. From this, I will try to rearrange the value. From independent events, you know that probability of A intersection B is equal to probability of A into probability of B. Try to substitute. Now I'll try to substitute the values. All the values are known. What is probability of A union B? 3 by 5. Probability of A half plus probability of B was given as an unknown. That is what we are trying to find. P minus probability of A is half into. So I have substituted the values of what is given in the data. Let me try to rearrange this. If I try to rearrange the values of this 3 by 5 minus half, I will shift it to LHS. I consider this to LHS. What is left out? P minus P by 2. Half into P, that is P by 2. 10 is the LCM. 5 2s are 10. So 2 3s are 6 minus 5 is equal to 2 is the LCM. 2P minus P. 1 by 10 is equal to 2P minus P, P by 2. I'll continue here. If I continue here, I cross multiply 2 by 10 is equal to P, 1 by 5 is equal to P when it is independent events. I simplified the fraction, 10 is the LCM what I took. So 5 2s are, 2 3s are 6 minus 2 5s are 10. 5 into 1 is 5. Here I consider 2 as the LCM, 2P minus P. 6 minus 5, 1 by 10. 2P minus P, P divided by 2. 2 cross multiply, 2 by 10, I get it back 1 by 5. So value of P they had asked us to find when two conditions are given. When they are mutually exclusive, I got back the value of P as 1 by 10. When they are independent events, I got back the value of P as 1 by 5. The next problem what is asked is, let A and B be independent events with probability of A is 0.3, probability of B is 0.4. They are given in terms of decimal places. Find probability of A intersection B, probability of A union B, conditional probability of A when event B is occurred, conditional probability of B when event A is occurred. Let us see how to rearrange. They are given A and B are two independent events and the values of the two individual events. Using that, let us find out. Given that A and B are independent events, what does it imply? If they give A and B are independent events, it implies that probability of A intersection B is equal to probability of A into probability of B. When I say A and B are independent events, It implies probability of A intersection B is equal to probability of A into probability of B. Now, probability of A intersection B is equal to, what is probability of A? 0.3 into probability of B is given as 0.4. From the definition of independent events, if A and B are independent events, I get probability of A intersection B is equal to probability of A into probability of B. We'll rearrange that. Probability of A intersection B is equal to 0.1. 3 fours are 12. There are 2 decimal places after each one, so it is 0.12 what I get. Have rearranged in the form of the decimal place. Then the next one asked is probability of A union B. If I have to find probability of A union B, I can use the formula probability of A plus probability of B minus probability of A intersection B. This is the formula what I can consider when I have to find probability of A union B. Probability of A union B is equal to probability of A is given as 0.3 plus probability of B is 0.4, and you already found the value of probability of A intersection B using the condition, that is minus 0.1. So what do I get back? 0. I'll add up these two, 4 plus 3, that is 7, minus 0.12. I'll subtract this. Carry 1, 10 minus 2, that is nothing but 8, 6 is left out, 6 minus 1, 5. 0.58. Probability of A union B is 0.58. With this, I have to find conditional probability. To find conditional probability, I will consider here only. The next one, conditional probabilities of 2 are to obtain. What is the first one I need? Conditional probability of A when event B is occurred. Conditional probability of event A when B is occurred. Conditional probability is defined as probability of A intersection B divided by which event is occurred? Probability of B. Conditional probability of A when event B is occurred is given by probability of A intersection B when event B is occurred. Probability of A intersection B we found in the first condition. It is 0.12 divided by probability of B was given in the data. Can I say 0.3? 4 3s are 12. So rearrange that 0.3. Then probability of conditional probability of B when event A is occurred. Probability of A intersection B divided by which event is occurred? Probability of A. Conditional probability of B when event A is occurred is probability of B intersection A or A intersection B, one and the same, divided by which event is occurred? A. Now, what is the value of this? A intersection B probability is 0.12 divided by probability of A was 0.3. If I simplify this, I get back the value as 0.4. So this is how you rearrange all the 4 conditions. Okay, the next one. If A and B are 2 events such that probability of A is 1 by 4, probability of B is half, probability of A intersection B is 1 by 8. Find probability of not A and not B. I have to obtain the probability of A dash and B dash. So here they've given A and B are 2 events such that the individual probabilities and the intersection of that is given. In this case, I can look at the problem and say that it are independent events. Can I not say they are independent events? Probability of A intersection B is 1 by 8. Probability of A into probability of B is nothing but 1 by 8. So from the given data, I can say the first condition is they are independent events. Then they have asked us to find this. So from the given data, Given probability of A intersection B is equal to 1 by A. Then I consider, given already probability of A intersection B is 1 by A. I consider probability of A into probability of B. What is probability of A into probability of B? 1 by 4 into 1 by 2. That is 1 by 8. When I compare these two from equation 1 and 2, from equation 1 and equation 2, can I say probability of A intersection B is equal to probability of A into probability of B? From the given data, I can verify this. Given already probability of A intersection B is 1 by 8. I have considered the product, probability of A into probability of B, I am getting 1 by 8. From equation 1 and 2, I can say that probability of A intersection B is equal to probability of A into probability of B. That implies A and B are independent events. That implies A and B are independent events, because this is the condition what it has to satisfy. It has satisfied that condition. Now I find out what is probability of not A intersection not B. That is when you write the complement, that is A dash, you denote it as A dash. So here we used to use in sets complement as A dash. Now we can denote it as A to the power of bar. Not A means it is A bar bar. If I have to find the value of this, can I say since A and B, just now we considered they are independent events, I get back probability of A bar into probability of B bar. From the given data, I verified that they are independent events. Yes, I got back it is true. Probability of A intersection B is equal to probability of A into probability of B. To find this, I'm going to use that condition. Probability of A bar intersection B bar is equal to, since A and B are independent events, probability of A bar into probability of B bar. That is nothing but dash, the complement what I consider. We have also studied last year, if I have to find the probability of A dash, that is the complement, it is 1 minus probability of A. Probability of A bar is nothing but 1 minus probability of A. Similarly, if I replace the value for this, 1 minus probability of B. Probability of B bar is nothing but 1 minus probability of B. Now, 1 minus, what is probability of A? It is already given 1 by 4 into 1 minus, what is probability of B? It is 1 by 2. I've got the values of probability of A and probability of B. What is probability of A? 1 by 4. What is probability of B? 1 by 2. If I try to simplify this, 4 is the LCM, 4 minus 1, 3 by 4. 2 is the LCM, 2 minus 1, 1. So that is 3 by 8. Probability of A dash intersection B dash, not A intersection not B, is equal to 3 by 8. This is the value what I get back. So since in this problem, it was not directly to be found probability of not A and not B, I verified the condition that A and B are independent event. I used that and tried to find the value. Probability of not A and not B is equal to 3 by 8. This is the value what you get back. So these are the few problems what we worked out in today's class on independent events. Next class we'll consider a few more problems on these independent events.